Characteristics of a wave. The first characteristic is the amplitude. Amplitude is the maximum displacement of the medium's particles from the equilibrium position due to the propagation of the wave through it. Symbol A or Y max. The following diagram represents the variation of the displacement of the medium's particles through which the wave propagates as a function of time. So the dotted line mark here represents the maximum point. The distance from the equilibrium position to the maximum point is the amplitude. So give the amplitude of the wave represented in the adjacent figure. Y max equal 4.5 centimeter, which is equivalent to 0.045 meter. We divide by 100 when we convert from centimeter to meter. So now how did I tell that it is 4.5? Let's check the scale here. From 0 to 2, there are 1, 2, 3, 4 subdivisions, and it is equivalent to 2. So 2 divided by 4 in order to find the value of each subdivision. 2 divided by 4 is 0.5. That's why every subdivision is 0.5 centimeter, and thus the amplitude here is 4.5 because it is indicated on one subdivision above 4. The SI unit of any distance parameter is for any distance is parameter, and the displacement here is considered to be a distance. Now the second characteristic is the frequency. Wave frequency describes the number of waves that pass a given point in a unit of time. The number of waves or the number of pulses that pass a given point in a unit of time. The adjacent diagram represents the behavior of the particles of the medium as a function of time, their amplitude as a function of time. Calculate the frequency of the represented wave. So the rule is F equal N over delta T, where F is the frequency in hertz, N is the number of waves, and delta T is the duration in seconds. So how many cycles are present here? This is the first one. 1, 2, 3, 4. So N equals 4. Delta T is F equal N over delta T, which is equivalent almost to 4 over 35 minus 10. 4 over 25 seconds is 0.16 hertz. So instead of writing cycles per second, we have to use the SI unit hertz, abbreviated by capital HZ. Period. The period of a wave is the time required for one complete cycle of the vibration of the medium's particles. As a particle of the medium complete one full cycle of vibration at any point of the medium, a complete wave passes through this point. So calculate the period of the represented wave aside. As you can see here, the rule is T equal the period, capital T is the period, equal delta T, which is the duration, for n number of waves, where T is the period in seconds, n number of waves, and delta T is the duration in seconds. So in this case, let us count how many periods are there, or how many cycles are there. Again, there are 4 cycles represented here, just like the one before. And delta T is 35 minus 10. So we take the whole time, the whole duration, and divide it over the number of cycles to know what is the time needed by each cycle. So we get the following answer. Now the wavelength. The wavelength is the distance covered by the wave during one cycle. Now we have to use the representation of the amplitude as a function of position x, because wavelength is the distance covered by the wave during one cycle. However, before, when we wanted to find the period or the frequency, we had to use the graph that represents the variation of the amplitude as a function of time, because we were looking for a time factor. Now we are looking for a position factor. Indicate using the adjacent figure the wavelength of the represented wave. So lambda could be measured between two consecutive crests or two corresponding points in phase on the equilibrium position or two consecutive troughs. So here lambda is given in centimeter, we have to convert it to meter. According to the graph, between 5 and 10 almost, or between 4 and 11, or it is here like 4.5 and 11, so 11 minus 4.5 is equal to 6.5, not 5. For the exam it's going to be clear. Okay, it's going to be clear, don't worry about it.